This is 8th grade geometry standard number 3, part 3. Our learning target for this video is I can describe the effect of rotations using coordinates. So we're specifically going to be looking at how our coordinates change when we do a rotation. This is the most complicated of the 3 rigid motion transformations. We have 4 things that we need in order to perform a rotation. The first one is a pre-image, and we know that from class that we have to have an object that we are going to transform. The second thing that we need is a center of rotation. Now, a center of rotation could be on the figure itself, so I could rotate around point C, for example. It could be off of the shape, which is what we're going to be doing. We will be rotating around 0, 0, which is the origin. Or the center of rotation could be inside of the figure. So I could have a point right here in the center, or really a center of rotation can be anywhere. The third thing that I need is an angle of rotation. 90 degrees, 180 degrees, 270 degrees. These are the most common, and these are the amounts that we will be rotating in this lesson, and the ones that we will be talking about most in class. Now, I can rotate any amount of degrees, but these are the most common ones and the ones that we will be discussing. The final thing that I need in order to do a rotation is I need to be given a direction. I need to be told if I am rotating clockwise or counterclockwise. If I don't know this information, there are 2 different places I could land. Rotating 90 degrees clockwise puts me in a different location than rotating 90 degrees counterclockwise, except for one thing. If I rotate 180 degrees, 180 degrees is a half turn. So because it is a half turn, I do not have to be given a direction. If I rotate 180 degrees clockwise, I land in the same place as if I rotate 180 degrees counterclockwise. So this is the one that we are going to start with. We are going to begin by rotating figure ABC, triangle ABC, 180 degrees, and it doesn't matter if I go clockwise or counterclockwise. So here's my center of rotation. It is the origin, 0, 0. In order to do a rotation, I am going to draw a hook, which is a vertical line and a horizontal line that connect my center of rotation to the point that I am going to rotate. Now that I have my hook, I am going to rotate it 90, 180 degrees, and I'm going to bring that hook over so that it is connected to my center of origin, and I'm going to draw my new point. Here is my new point C, which I will call C prime. And then I'm going to go ahead and get rid of this hook because I don't need it. I'm going to jot down the location of C prime. It is located at -2, -2. And I'd like you to start looking at how the original coordinates of the pre-image have changed when we did this rotation. Let's do the same thing for point B. I'm going to draw my hook, vertical and horizontal line, and I'm going to rotate that hook 180 degrees, 90, 180, and I will bring this over to my center of origin, and that's going to show me where my new letter B is located. My new letter B, which I will name B prime. And I'm going to go ahead and get rid of that hook. I don't need it anymore. I'm going to jot down the location of point B, B prime, -5, -2, and go ahead and take a look at how these coordinates have changed. And my final point, point A, drawing my hook, rotating that hook 90, 180 degrees, and connecting it to my center of origin, or my center of rotation, which is the origin, and creating my new point A, which is located down here, A prime. Get this hook out of the way so it's easier for me to see the location of point A prime is at -1, -5, and recording that information here. I'm going to connect these dots. My points A, B, C. It appears that my triangle is the same shape and the same size as before, which means that my pre-image and my image are congruent. My shape did not grow, it did not shrink, it did not change shapes, therefore it is congruent. And in fact, we've learned that all of our rigid motion transformations, translate, rotate, and reflect, will create congruent shapes. So the question now, in relation to the coordinates, how have the coordinates changed? How have my x and y become different after doing this rotation? I'm going to go ahead and highlight our x's so that we can look at them a little bit more carefully. My original x's were 1, 5, 2, and now they are -1, -5, and -2. And let's go ahead and take a look at our y's, 5, 2, and 2, and they are now -5, -2, and -2. So what has happened to our x and our y values? It looks to me like we have ended up with the opposite of x. Yes, all of these points became negative, but we're going to be really careful that we don't say -x. We're going to say the opposite of x. What happens sometimes is if we say the negative of x, is that sometimes if x was already negative, students won't change it to become positive, which is really what should happen. Our x values all changed to the opposite of what they were. What happened to our y values? It looks like all of our y values also became the opposite of what they were. So we'll put a negative sign here also, but I want you to know and use the word not negative. We're going to use the word opposite, the opposite of y. That lets us know that whatever y was, we will be writing the opposite of it. And we've talked about this in class. We've talked about how if you are on a really bad path and you want to turn your life around, that you are actually turning 180 degrees. That's the opposite of what you were doing before. So in fact, rotating 180 degrees is going to give us the exact opposite of what we had before. So if I move this out of the way, you're going to see that we have some rules that we are going to be filling in. And we just discovered one of them. We discovered that if we rotate 180 degrees clockwise, which is also 180 degrees counterclockwise, that our x becomes the opposite of whatever it was, and our y becomes the opposite of whatever it was. We are going to do the same thing for 90 degrees and 270 degrees. So for 90 degrees and 270 degrees, I do have to be given a direction. So let's go ahead and do 90 degrees clockwise. We're going to use this same shape, and I'm going to do the same process as before, but I'm going to move a little bit quicker. I'm going to connect the origin over to point C with my hook, and I'm going to rotate that hook 90 degrees clockwise, and I'm going to bring it down. Oops. Bring that hook down here, which will land my new point C, which I will call C prime, and its location is 2, -2. So you should start looking for those patterns, what is happening to our coordinates. Here's my hook for letter B. I'm going to do the same thing where I rotate B 90 degrees clockwise. That is going to land my new point B down here. I will name it B prime. I'll get this hook out of the way so that I can see, we'll get this hook out of the way so that I can see that the location of B prime is at 2, -5. Ooh, something weird happened there. Take a look at where B was and where B prime is. And our final point, which is point A, connecting with my hook, and then rotating this 90 degrees clockwise, bringing it over to my center of origin, and marking the location of my new point A, which I will call A prime. Getting rid of that hook. Again, making that mistake, sorry. Getting rid of that hook and marking the location of A prime, which is at 5, -1. I'm going to go ahead and connect all of my points. I can see that this triangle is the same shape and size as it was before, which means it's congruent. We already knew that was going to be the case. But now we want to take a look at our coordinates. And using coordinate notation, we're going to try and figure out how X and Y have changed. So let me grab my highlighter again. I'm going to mark the X values of the original first. The X value of the original, 1, 5, and 2. Take a look at the location of my image and look at where 1, 5, and 2 appear. They actually appear in the Y's location. My X's have moved into the Y position. This is really different than what we have seen before. So this is the X location, this is the Y location, but look what has happened. My X's are now in the second position. My X's are now in the second position. Now, do they look exactly the same? 1, 5, 2, -1, -5, -2. They are not the same. What has happened to them? We're not going to use the word negative. I know I just said it 3 times, but they have become the opposite. The X's moved to the Y location and became the opposite of what they were. Opposite of X. All right, let me grab my other highlighter so that we can take a look at our Y values. Here are my original Y values, 5, 2, and 2. Now look where my Y values landed. My Y values are now in the X position right here. So what has happened is my Y's have moved to the X position. Now, do they look identical? 5, 2, 2, 5, 2, 2. They do. So what happens when I rotate 90 degrees clockwise is the X and Y change positions, and the X becomes the opposite of what it was. We're going to write that down in our table, and I would like for you to make a prediction of what will happen when we do the final one, which we will take care of in class. We just did clockwise 90 degrees. The X and Y changed position, and the X became the opposite. What happened when we rotated 180 degrees? We got the exact opposite of X and the exact opposite of Y. That's because rotating 180 degrees, a half turn, is the exact opposite of what you were doing before. I would like you to make a prediction of what you think is going to happen when we rotate clockwise 270 degrees. We will do that in class.